Hello, Jeff Zwerink, and welcome to Give and Take, the segment of our show where we explore important scientific ideas to help you be more convinced and confident in the truth of Christianity. Today, we're joined by Dr. Fazale Rana, and we are going to explore why there are different versions of the COVID-19 vaccine. Fuz, it's good to have you here today.
Jeff, thanks for having me.
So this strikes me as a little bit odd. I mean, we just have, in the past, there's a vaccine for polio, vaccine for mumps, measles, and rubella. They might put a bunch of them together, but I don't recall there being different vaccines for the same thing. Why are there different vaccines this time?
Yeah, well, and maybe to help answer that question, we can just do a quick review as to what happens when a virus invades our bodies, right? You have these viral particles that are floating around in our bloodstream. They are inside cells, and our body mounts an immune response to the viral invasion, if you will. And part of that response is to produce proteins that are called antibodies that will specifically bind to the virus. Those antibodies only recognize that particular virus, or the immune system will produce these cell surface receptors that again will only uniquely bind the virus. And so once that happens, we now have what's called acquired immunity. If we are ever exposed to that virus again in the future, our bodies and our immune system will remember that infection because of these antibodies and these cell surface receptors. So what you do with a vaccine traditionally is take a virus and either heat inactivate it, or you attenuate it so it's still alive, but it's no longer infectious, and you inject the patient with that. And then that causes the body to mount an immune response to that, again, deactivated or attenuated virus. And as a result, we get essentially immunity without having to go through the disease itself. So most vaccines are in these two categories, again, either heat deactivated or attenuated viruses.
So in those, basically you're introducing the virus into the system and allowing your body to mount an immune response to kind of the way it would normally, but just kind of controlled it so that it's not going to be so dangerous, if you will.
Yes, that's right. You've kept the virus from actually causing you symptoms of the disease, but yet you still get the benefit of the immune response. Now, the second generation of vaccines, which is what we're seeing with COVID, are vaccines with the idea of introducing not the virus itself, but parts of the virus, particularly those parts of the virus that are on the surface of the virus that our immune system is going to interact with. So for COVID-19, the vaccines in many instances involve introducing the spike protein to our bodies. And so our bodies mount a response to the spike protein, and hence we develop immunity to the virus, to the COVID-19 virus. So this is why there's so many different vaccines, is because people with COVID-19 are exploring different variants of these second generation vaccines. And the reason why is because these vaccines are actually easier to develop. And once you have the vaccine, they're easier to produce, and they can be produced much faster at much larger volumes. So there's strong motivation to explore these second generation vaccines.
Okay, so in the past, we were basically taking the virus and introducing it in and allowing the body to mount a response, which there's really kind of one or maybe two ways. You said you either you kind of had two ways of introducing the virus. Now we've got where we're introducing various parts to trigger the response. And in principle, there's multiple different ways we could do that, which is presumably why we've got the different vaccines, correct?
That's exactly right. And so most of the vaccines that we are going to encounter here in the United States and in Europe are going to be vaccines in which we're introducing the spike protein into the patient's body, and the vaccines, these vaccines are going to trigger an immune response to the spike protein and hence to the SARS-2 coronavirus. But there's different ways that you can introduce that spike protein into the body, which is why there's even more options that we have with regard to the SARS-2 coronavirus vaccines.
So kind of specifically with the Pfizer, BioNTech, and the Moderna, and then now we've got this Johnson and Johnson one that's coming out, at least here in the U.S. I know there's AstraZeneca and Novavax. There's other ones in other parts of the world. But what are the differences between those three, the Pfizer, BioNTech, the Moderna, and the Johnson and Johnson?
In a sense, the Pfizer, BioNTech, and the Moderna are more or less the same vaccine. There's some, subtle differences from vaccine to vaccine depending upon the company producing them. But these are all messenger RNA vaccines, which in a nutshell introduces a biomolecule called messenger RNA into our bodies, which codes the information needed to make the spike protein. And then this gets taken up by cells that produce the spike protein and then present those spike proteins to the immune system to trigger the immune response. The AstraZeneca and the Johnson and Johnson vaccine, as well as what's called the Gamaleya vaccine, which is produced by Russia, are all three what are known as viral vector vaccines. They all use the adenovirus and they incorporate the gene for the spike protein into this adenovirus. And then they inject the adenovirus into our bodies, and that essentially invades our cells and causes our cells to produce, again, the spike protein. These adenoviruses, however, are modified so they can't reproduce in the cell and they can't incorporate their genetic material into our genomes. And so they're safe vectors or delivery agents, but it's a different strategy for delivering the genetic information to the cells to produce the spike protein.
So as you cash it out, what do you see as the positive and negatives of each of these types of vaccines? Is there one should we wait for one instead of the other, or how would you assess that situation?
Yeah, well, I mean, in a sense, all three of these vaccines, the Pfizer, BioNTech, Moderna, and the J&J or the Janssen vaccines are all safe, and they all are highly effective at preventing hospitalizations with COVID-19. It looks like the Pfizer, BioNTech, and the Moderna may be more effective at preventing actual COVID infections than the J&J vaccine, but that's still being disputed by experts as to whether that's the case or not. So they all are safe, and they all are highly effective at doing what we really need them to do, which is prevent hospitalizations from COVID-19. Where we see differences is primarily in the handling of the vaccines once they're produced. Because the Pfizer, BioNTech, and the Moderna vaccines are messenger RNA vaccines, they're highly unstable and they have to be kept at extremely cold temperatures, which really creates nightmares when you're trying to distribute the vaccines and then deliver the vaccines to patients. Whereas the J&J and the AstraZeneca can be handled at much more moderate temperatures, so they're easier to distribute and to administer. That, to me, is the primary difference I see between those vaccines in terms of safety and effectiveness.
Well, thanks, Fuzz. I really appreciate your comments. When it comes down to it, how we handle the COVID-19 vaccine and the viruses and the diseases and how we take care of others, really it's important that we have good information so that we can make wise and prudent decisions. And I appreciate this information that Fuzz has given. I would encourage you to go to reasons.org and check out Fuzz's blog on these latest vaccines. It's called The COVID-19 Vaccines and God's Providence, that will help equip you, give you good information so that you can make a wise decision, not only for yourself, but for those around you.